Okay, I believe we have sound. I believe we have sight. Uh, so let's see if we can muddle our way through this section 2 from the core module. Uh, uh, I'm in the core in the. I'm sorry. I'm doing this video because my directions for the week 3 assignment were confusing, and the more I worked at them, the worse they got. But so now I've decided to do a video and see if I can clear up what needs to be done here. And I'm not starting off very well, but maybe I'll get better. Uh, we're going to try to muddle through, uh, explaining some things as we go. For this week 3 assignment, which is located in that in your I think I got a link to the section 2, what I call soil section 2, and I have the video open to the page where the scenario that is talked about is located, and that's what you should be looking at. Now you're also looking at some cubes that I don't like to use to uh, to illustrate shrink and swell. I stay with the math, and I will throughout this little scenario. The the biggest deal that about this scenario is just settling down and reading it. I took notes the first time I did it so I could even talk about it. So let's just start talking. So this is section let me get my arrow on the right computer screen. This is section 2.3.1 in that soil section 2. If you remember, I broke up the module 22308 NCCER soils so that we wouldn't have such an upload time and a download time. So, and I'm going to try to get through this a little quick uh, because I want to get it up hopefully later tonight. This happens to be Wednesday, the 24th. So I want to get it up about sometime tomorrow. So before you have to do this assignment, you will be able to go through this module. It'll be a close call. So don't fool around. Get to the video, get the assignment done. Uh, and then fiddle around with the tailgates and other things, perhaps. Okay, it starts out saying, let's assume that you need to excavate some damp sand from a borrow pit and take it, that means you're going to haul it somewhere, to a building site. The sand has it's damp sand, I think. It has a bank weight that's in its natural state in situ of 3,200 pounds per cubic yard, and it has a loose weight of 2,850 pounds per cubic yard. And this information is located on table 6. Now don't go there because I think it says something different than it's saying here. So let's stick with 3,200 bank weight per cubic yard, 2,850 loose weight per cubic yard. You remember those, I'm thinking. Now, what we need to do is we need to fill up an area that has the whole has a volume of 100 cubic yards. The material has a shrink factor of 0.8, 8/10 when it's compacted. Now, so we got to figure out how much loose sand we're going to need so that when it's compacted, it's going to come out to, we got to take in consideration the shrink factor of 8/10. And it says this may be confusing. So it's referred to figure 21A, and that's what they're talking about. This figure I do not like. Just trust me on the math. First, we got to determine how much fill is needed. Now, the fill is going to be loose, isn't it? So since the compacted volume is 100 cubic yards and the shrink factor is 8/10, you need 125 cubic yards of loose fill to end up with 100 cubic yards of compacted fill. So the way you get how much loose fill you need is you divide the amount of compacted fill, the dirt that you don't have yet, that you're going to need, by the shrink factor. So 100 needed 100 cubic yards of compacted material to find out how much loose material I need, so that when compacted, I'm going to have fill up 100 cubic yard hole. I divide 100 by 0.8, and that tells me I'm going to need 125 loose yards. You know what the first thing I did right here, and I didn't do this last time I taught this. I went straight to the calculator first, and I took 125, and oh my goodness, have I already lost my notes? I took 125 and multiplied it times 2,850 pounds per cubic yard. The reason I did that is I wanted to know the total weight of that soil that I had to bring over to that site. So when I multiply 125 cubic yards times 2,850 pounds per cubic yard, I came up with 356,250 pounds total weight of soil. Now, I'm not going to cheat and tell you that you could solve the problem with that information, but I think you can. But I want to go through it. I want to go through it with you. So we've made it through the first step of finding out that we need 125 cubic yards of loose fill to fill and compact that 100 cubic yard empty hole. Let's go on. That's the first thing we did. We came up with that 125 cubic yards. Now, let's see what they tell us to do. The second thing, I'm reading the wrong. No wonder it's hard to read. I'm reading what you read on. It's a little bitty. The second thing we need to do, as I scroll this up too far, is to calculate the swell factor of the excavated material. Now, we're going to need to know that. We're going to calculate the swell factor of the excavated material that came out of the hole. Since the bank weight of the material is 3,200, the pounds per cubic yard is 3,200 pounds per cubic yard, and the loose weight is 2,850 pounds per cubic yard. The swell factor of that material we're bringing is 1.12. 3,200, 2,850. That's what we're bringing in. Now, oh, and this is telling us how we came with that. We took the bank weight and we divided by the swell weight. We learned that a while back, but you may have forgotten. But that's the way you calculate the swell factor right here, is divide the bank weight by the loose weight. The third thing we need to do is, well, it tells us you already know you need 125 cubic yards of fill, this stuff. But the question is, how much bank material do I need to dig up to get that 125 cubic yards of fill? This is calculated by dividing. We're taking bank yards and turning it into loose yards. This lost my place. This is calculated by dividing the desired amount of fill, 125, by the swell factor. So 125 divided by the swell factor equals 111.6. So 111.6 cubic yards of bank material needs to be excavated to get 125 cubic yards of loose material. That's what we need. Now, also, this is something else we're not going to do. It says to prove that this calculation is correct, go through the problem backwards, see figure 21b here, and which I'm not going to do. You can. When 111.6 cubic yards of fill is excavated, it swells because of the swell factor. It swells to 125 cubic yards. And the reason I know that is, or they know it, is that the swell factor is multiplied. I'm sorry. The 111.6, the amount of cubic yards that we're digging out, is multiplied by the 1.12 swell factor, which gives us 124.9, which rounds off to 125, which we need. When this material is compacted, it shrinks to 100 cubic yards because it has a shrink factor of 0.8. And 125 multiplied by that shrink factor equals 100. So you go backwards and forwards on this thing. Now, if you want to go back through that, we're not going to do it. It's nighttime here, and because I want to get this up and posted. It's going to be recorded, so it'll be in your module 3 tomorrow at some point. So the whole thing here is to, as it says up here, is to select the truck that best suits the needs of this excavation based on weight and volume. Now, Table 7 shows the volume and weight capacity for 3 articulated trucks. It tells us that your instinct is probably telling you to select the truck with the largest payload, the biggest truck, so you can get your work done quickly. This is a good instinct, but you need to check that the weight capacity is acceptable for the material you're going to haul, because the cost of operating a large truck is greater than that of using a smaller truck. You already know that weight of loose material is 2850 pounds per cubic yard. So you need to calculate the loaded weight of material. Now, let's see, where is that table I'm looking for? Oh, here we go. Truck A has a capacity of 18.8. If you that is its weight, its volume capacity is 18.8. Wait a minute. Volume, capacity, heat. Oh, that's how much weight it'll hold. It's capable of carrying, but you take that 18.8, multiply it by 14.5, which is the volume capacity, is how much you can get in there. Your weight is 52,000 pounds. Now, that's the rated payload. The truck B, you go through the same scenario, and its payload is 62,000. You go down here to truck C, and it can carry it. volume capacity is 30, and its struck capacity, I'm sorry, I've been saying this is heaped and this is struck. Its struck capacity is 22.8. That's 84,000 pounds. Now then, that's the capacity of the truck. Now, remember what I said I did in the very, very beginning. Now, I didn't do it like this, but let's see what they did. They took heap weight of truck A right here, 18.8, and they multiplied it times 2850, and they got 53,580 pounds. Now, that I think exceeds the weight capacity of the vehicle. That's the last figure. Okay, so the struck weight, that's when you level the top off. The struck weight is 14.5 right here, multiplied times 2850, which is 41,325 pounds. Now that's I lost my place. That might work, but let's move on. This is within the weight capacity. That might work. Okay, so let's look at truck B. I mean, it will work. It's just going to take you a little bit longer. Truck B is heaped at 22.1 cubic yards. That's how much it'll hold when it's heaped. And you multiply that by 2850, that's 62,985. So that exceeds the weight capacity. The struck weight is 48,735 pounds. And that's within the weight capacity, but it's going to take you on. Look at the heap weight in truck C. It's 30. Multiplied that 85,500. Now, I guess you might say this truck is going to work, but is it really? So the reason I say that, go back to what I first said. I first said that the total weight of this whole, all this dirt that I'm going to carry over there is 356,250 pounds. That's how much all of it weighs. And I want to get all of it over there as soon as I can. So let's take truck A. If you take 750 pounds, total weight of all that material we need to take over there, and divide it by the capacity of 52,000, you will end up with 7. So that truck is going to take, that truck 7 trips to get that dirt there. Now, look at B. It's 62,000. Now take that 356,250 pounds divided by 62,000, because that's all it can carry at once. And you get 6 trips. Now then, take truck A. Its capacity is 84,000. So it can carry 84,000 pounds every trip. So take 356,000 divided by 356,250 pounds total divided by 84,000 pounds, and you get 4 trips. Truck A would not require 9 trips. Truck B, I don't know what I said, but I do know that I could get that dirt over there, that 125 cubic yards of dirt over there, in 4 trips using truck A. So I'm not really interested in, it's just not the way I would do it. I may be missing something here, and maybe they come up with something, maybe they saw something, but to me it's simple. You just take all the total weight of the dirt of the soil you got to transport, and you find the truck that can get it there, whatever its capacity is, in the least amount of time. And I feel like that's what I did by taking the total weight of all the dirt we need, the 125 cubic yards, and dividing it by the capacity of each truck. And that tells me how many trips. If you find something wrong with that, I won't be embarrassed. I'll be happy to listen to you. But I think that that's the best way to do it. Uh, get in touch with me if you just still can't muddle your way through this thing. I'd like to see everybody try to work it just for your sake. Uh, this is what they come up with. Have I even uh, do they say which one to use? I don't even see where it says which one they want you to use. Hmm. Best suits, table 7, select a truck larger class, so you already know. It just goes and tells you. I don't think it solves it. I thought it did. Anyway, I feel like I solved it. So truck A is the one you want. In this case, it's the one that'll carry the most per trip. And that's what you're really looking at, is what 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 truck can carry the most weight per trip. We know how much total weight we got to transport. So I'm going to leave it with you right there, and I'm going to post this so you'll have time to go through it. Please don't submit your assignment and just say truck A. Show me something that you did. Show me what I did. I want to see that you understood this while you were going through it. And again, you can get in touch with me with questions, etc., as in the usual way. And otherwise, I guess that's all for now.